All right, let's do it. Let's go ahead and with the static analysis piece. So in the static analysis piece, what we want to try to do is we want to play with some malware. So in this next one, we have a file, which is the Wannacry malware. So I've got the Wannacry malware in here. And I'm going to run the file command against it. So the file command lets me know that this file is a portable executable file. So a portable executable file in Windows, we call these PE files. We've got this portable executable file. Now, if we go look at Gary Kessler's file signatures link, this link is Gary Kessler's a really famous forensics guy. And let's say I look for MZ right here. So do you guys see this 4D5A? I need you to think of like a file in Windows. Like if this was the file, that 4D5A would be in the top left corner of the file. It would be the file header. And what operating systems do is they read the file header so they can figure out, oh, this is the beginning of the file. And then they read the file trailer to figure out what is the end of the file. So let's say, for example, if you had a PDF file, this would be the file header. And then over here would be the file trailer. And that way you would know, at least the operating system would know, hey, that's the beginning over there, and that's the end of the file. So what antivirus products will do is they will read the file header, and then they'll search for a specific distance in the file and look for a specific block of text. And that's how they tend to do file signatures. Now, as we look at stuff, we can go, all right, now I know what kind of file it is. The next thing I would probably do is I would probably obj dump it. Obj dump is a way that I can look at the data structure of a file. So this allows me to look at the data structure of a file. Now, as you look at the data structure of the file, there's a lot going on in here. So oftentimes what I think the easiest thing to do is to probably get another executable and probably compare against them, right? So what I'm going to do is I'm going to go up here and I'm going to grab putty.exe just so I can have another executable to play with to try to compare the two. So I'll wget putty. I've yanked down the file putty. Okay, and now instead of doing an obj dump on Wannacry, I'll do an obj dump on putty. And now let's go take a look at it. Whoa, boy, it's got a lot in that file, right? So it's got so much I can't even scroll up in it. So what I'm going to do is I'm going to run the obj dump command and I'm going to pipe it to less. Okay, so let's see. Okay, it looks about the same so far. All right, so it's got the architecture. Okay, executable. Okay, major linker version, that's the compiler. Major OS system version, this is the operating system it was built on. So it was built on Windows 5.1, which if I'm not mistaken is Windows XP. So it looks like the first time they built it on that, and then they haven't changed any OS information since they built it. All right. So now we've got this data structure stuff. Here, you're going to find a lot of people analyze this stuff to see if someone has mangled the header. Oftentimes, mangling the header, mangling the PEB or TEB, process execution block, or thread execution block, is a really good way to figure out if something is malicious. So I don't have time to really get into this, but you will see people who mess with this stuff when they're trying to obfuscate files. What I can tell you is probably the fastest thing to do is to look and see what DLLs are called. So right here, GDI32.dll, graphic display interface.dll. Inside of that DLL, these functions are utilized. Whoops. So if you want to learn about what the executable is capable of doing, search the DLLs, because each DLL, the functions inside of it, will tell you what this malware is capable of doing. So let's say I want to go look at Wannacry. I'm going to do the same thing. I'm going to come down here and I'm going to look at these DLLs. So it's got kernel 32. And if we get down in here, look at ADV API 32.dll. It can create a service. It can start a service, reg create key, reg set a value, query a value, open the service manager. So you start looking at that and you start going, man, what legitimate file needs to be able to manage services, right? Or modify the registry. So as you go through this malware, you start to say, okay, for what this malware claims to be, is this legitimate functionality? Like if this is claiming to be a screensaver, should it be able to modify the registry and modify services? Probably not services. But if this is remote administration stuff like Dameware or remote desktop or something like that, yeah, it probably does need to be able to connect to the network. I would say what most of us do is we use a tool called strings. Strings allows you to look at ASCII human readable content from a binary file. So as I run that, at the bottom of the file, it'll show me all the human readable text. See all this? This is all human readable text. And I can learn what the malware is capable of doing using the strings command. So what I'll do is I'll strings and I'll grep for DLLs. And now I can see what DLLs are in use. So the DLL tells the story. The DLL tells you what it's capable of doing. So let's say you've got ws2_32.dll. So what you would do is you would just say, you know, what is that DLL? And you'd see that it's the DLL that handles network connections. So now we know that this malware is network aware. So you can go, okay, based on the DLLs that are in use, I can see what this thing is doing. It's capable of connecting to the network. So then I'll ask what the next DLL does. So this does OLE, object linking and embedding. Okay, so again, you're going to see this when Windows needs to interact with other applications. OLE is oftentimes used inside of Office documents, object linking and embedding, so you can embed stuff, right? So if apps need to communicate with each other or they need to authenticate to each other, that's what the AUT part is for. ADV API 32 manages the registry. So we use this to try to figure out what the malware is capable of doing. This is called static analysis. Static analysis is you trying to learn as much about the malware as possible without actually running it. So each of these things are things that you grep for. So like if I grep for the word library, last time I grep for DLL, now I'll grep for library, and I've got load library A and free library. Load library A is what you use to add functionality to a running process. So you've got a process that's running and you want to add functionality to it. So now that lets you know a couple things. We've got a file that can connect to the network. We've got a file that can do embedding and authentication. We've also got a file that can manage the registry and services. And it can also add functionality to itself at runtime. If you look for reg, you'll see how it's got close key, query value, set value. If you look for key, you'll see that it's got crypt gen, crypt destroy, crypt import. So you've definitely identified ransomware, not malware. You also notice that it's got a public key loaded in the file already. So that means that whoever has the corresponding private key is the only person who can decrypt files that this file encrypts. So this Wannacry malware will encrypt files on your local file system, and whoever has the private key can decrypt them. You've now identified ransomware. So this gives you a way to quickly analyze files by running just a few commands.
Don't forget to subscribe to this channel. I really want to get people to start using the channel, start hanging out on Infosecaddicts.com and hang out on the Infosecaddicts YouTube channel. Thanks so much. See you again in our next video.